Who am I? My name is Rico van der Laar. I live here in the Netherlands, and I'm a data and advanced analytical consultant at Data Heroes. And Data Heroes is my, there we go. Data Heroes is my own company. And I help organizations with data engineering and data science problems. And I mostly consider myself to be an applied data scientist. What that basically means is I'm more interested in making sure machine learning and data science gets into production, in a production process, than I'm necessarily interested in making the best model mathematically. So I'm not interested in bringing the accuracy of a model from 79% to 79.1, but I'm more interested in the process that if someone presses a button in an application, a machine learning model gets access, the prediction is being done and it's being written back again to the application. I'm Microsoft Data Platform MVP for the last 5 years, and I'm also a crazy data scientist. I brought some crazy data science stickers with me for after the session if you want to have them. And you should look at crazydatascience.com. And I'm actually tempted because this is the last session of the day. Are you guys a bit tired? A little bit, learned a lot today. I'm kind of tempted to go out with a little bit of crazy data science in this session. Would that be a good idea? Or do we want to predict car prices? Boo. No more car prices. Okay, I'm going to try to make it work. I'm also an author. I wrote a book on SQL Server weight statistics that I'm actually writing the second edition now, and I'm also working on another book, which is more on the big data area. I'm obviously a speaker, and you can find me at enricovanderlaar.com, and you can follow me blogging. All right. So we are going to look at a couple of things during this session. We're going to look at the advanced analytics workflow. And many times I use the words advanced analytics and data science to kind of mean the same thing. So when I say advanced analytics, I also mean data science, and more or less mean like, okay, machine learning. We're going to train a machine learning model, or we're going to do something with statistics and math, and we're going to do, we do that on an IT environment. And we're going to build and exploit some in-database models. Now, there were a couple of DBAs in the room, but I'm pretty sure almost everyone has a SQL Server machine in their environment. Are there any Oracle people here? One. You're very brave. I applaud your bravery. Does Oracle have something like in-database machine learning? They do, probably 5 years already. Okay. Anyways, it's rather new in SQL Server. We're going to see the various ways you can use it to kind of do machine learning directly inside your SQL Server database. And as a kind of a bonus, we are going to integrate Azure Machine Learning with in-database analytics, because you can do that if you want to. So first of all, advanced analytics then and now. A little trip down memory lane. How we would normally do data sciencey things. Traditionally speaking, you would look a little bit like this picture. We would extract data from a data source. We would send that data to a machine learning model that we train. That machine learning model could be on another machine or whatever. It would do a prediction, send it back again, in this case to the SQL database, and then send it back to your application. So consider a scenario in which you have a machine learning model, you've trained it on a whole bunch of data, and you want it to score data when a user fills in a web form. So the user would fill in the web form, data would get stored in your database, you would extract the data through some kind of process, send it to your model, predict, and send it back again, right? Sounds a bit familiar? So basically data movement. This is all good and fine, but you're moving data between different systems. You have to store it multiple times. It's not necessarily the nice way to do it, because it can be slow. It Consider if you're doing predictions like object detection. So you're sending across image files or maybe movie files or other large files. You would have to send it across multiple machines, which means it has to travel across a network, and traveling across a network always has to slow down. Even if it's a couple of milliseconds, it can really add up with large files. Data movement is always bad because network connections can fail, data can get lost somehow. You really don't want to move data. Technically, you want to keep it as close as possible to your machine learning model. And how are we going to do real-time scoring? So in the situation that I described just now, user enters data in a web form. We would have to send the data to the database, send it to the model, send it back again as a separate asynchronous process, or else the user would have to wait until our data is scored, which is another possibility. But if you're dealing with real-time data, like sensor data, and you want to act on it immediately before it's even stored, a process like this is impossible, because we need to store the data, move it to the other side, and send it back again. There are some, I'm saying impossible with a little impossible. If you're using Spark or Databricks with streaming enabled, you can do it in that area. But if you're doing it like in the traditional approach where you have a separate model stored somewhere, that's not working. Another big issue is where I always run into as applied data scientist is how are we doing model management and operationalization? Versioning. Who is storing the model? And I've come to customers that says, yeah, we have a machine learning model and we have it stored on this server, and yeah, our data scientists work on it, and it was a single R file that they ran using a command window on a scheduled task. And if a change was required, the data scientist would add a new line at the top of the file, version 1.2, and just change the code. So there's no versioning, there is no management. I doubt the machine was even backupped because it was like the traditional desktop underneath the desk that you couldn't turn off that has an R process running. So that isn't really nice. And I'm going to show you how that works. I'm going to show you the bad things first. They're not bad things. It's just how things work. And in some situations, that can be fine as well to run it like that. First thing we're going to do is we're going to look at our data. So I'm going to select some data. This is still automobile data, I'm sorry. Bear with me. This is data about cars. If you've been to my previous session, you can very confidently predict the price of this car in the top row. But this is all kind of features of a car, and we're going to predict the price. So what we would do is we would get some data. Oh, sorry, I need to go to this one. I got the wrong one. Forget the last 30 seconds. This is an R script in RStudio. It's familiar to people, RStudio? RStudio is great. We would need to get data from our source system. So what I would do is I would import a couple of libraries, an ODBC library, a dplyr, and I would get my data out of there. So in this case, I'm selecting everything from automobile. So basically the query I just did in SQL, I'm doing in R now across an ODBC connection. And I would get my data inside R. So this is, again, the same data as in SQL. I would split my data, because that's a good thing to do. When you're training machine learning algorithms, you would always split your data to have a training set and a testing set. So you would train your algorithm on the training data set, and then you would, to test if your algorithm is trained good enough, you would give him some data it has never seen before, but you've already know the outcome. So in this case, I know all the prices of these cars. I'm going to give the top 120 rows to train the algorithm. So it would train on that data, and I would keep 20 rows separately. So I know the price of those 20 rows, but I'm going to give them to the algorithm, and it's going to predict even as though it doesn't know the price. So I can compare the actual value with the predicted value and see how well we've done. That's basically the idea. So I'm going to run this. So I get two data sets, data tables inside R, and I'm going to do linear regression. So I'm using a linear model in R. This is what it looks like if you're not familiar with R code. I want to predict the price based on a number of features, or as SQL people like to call it, columns in my data set. So based on the wheelbase, the length of the car, the width of the car, the height, and some other things, I want you to predict the price. And linear regression, I've said it in a previous session as well, linear regression is awesome because linear regression is a straight line. So we try to always predict on that straight line. It's very simple to understand, easy to explain, and trains very quickly, unlike things like neural networks that can take days to train on data sets, depending on how complicated you make it. Linear regression is very quick, very fast, and absolutely the most used algorithm in the data science world, because it's simple and easy to understand. So I'm going to create our model. And this is machine learning. And it's done. And then we're going to score our data. So what I'm going to do is I'm going to select a random record from my data set. So consider this our situation where our user has entered data in his web form. We're sending it to the model now. So our model is selecting data from the database. Maybe normally you would do, okay, select everything from this table that doesn't have a predicted value yet or something. But in this case, this works fine. So I get a single observation, as R calls it, this one. And we know the price of this one because it's 0. So this is a new value. We haven't seen this one before. We're going to try and predict the price for this car. So I'm going to do predict. So predict is the R function that says, okay, give me the algorithm you've trained, give me the new data that you want to score, because doing a prediction, we like to call that scoring. So we're going to score that data, and we're going to add the scored value or the predicted price together with the value we already have. So I'm going to run this. Open it again so you can see what it looks like in R. And here you see the scored value is this car. We predict that the value of this car is $10,700 and something. It's all in dollars. And then we would have to save it. So in this case, I'm doing something very simple. I'm just saying, okay, save this data back to SQL again. Run. And now in my application, if I refresh this, come on. There we go. We have a score table. I'm going to select some data from it. Yes. It's a bit slow for some reason. It's busy. And here we have our data that we got from our R session with scored value. So this is the circle, right? So we would get our data out, score it, send it back again. All right. Back to the slides. So any questions about this? Does this seem logical? Yeah. Oh, I didn't test it with the data. I split it up, but I never tested it. I could do that, but it's only for the model accuracy. So this was the way we used to do things. But if you have SQL Server, we can do new things. What Microsoft developed with the release of SQL Server 2016 is what they called in-database analytics. And it was new in 2016, and they introduced it as R services in database. And what it allows you is to run that R code that I've just shown you directly inside SQL Server in a query. That's really cool, actually. So I can now run R code in SQL Server. And then they said in 2017, this is not good enough. You can now also run Python code directly in SQL Server. And everybody was just cheering like, okay, cool, so we can do all our machine learning straight in SQL Server. And with 2019, they're introducing Java So you can write Java code in SQL Server if you want to. I've never written anything in Java, to be honest, but there are a lot of developers here, so probably someone has machine learning algorithms in Java. But you can do that since 2019. The main key thing that they did, which is very powerful, is instead of bringing the data to your machine learning model, which we've just seen in our RStudio session, is we're bringing the model to your data. No more data movement involved. You can run your algorithms directly on the data on the same machine as where your data resides in your database. If you store your data in your database, of course. So if you have everything there, you're good. If you have it across multiple instances, you're a bit less good. But if you have all your production data in one database, then it's really going to work. It's really good. They also did a couple of more changes. I believe there is now a public preview for SQL Azure DB to also have in-database machine learning enabled. So you can opt in for that, and you can use in-database analytics in Azure DB if you want to. In 2019, they also made it high available. So it used to be like a single service that if your SQL Server crashed, all your machine learning would stop, even though it was on a cluster. It's now cluster aware, so you can really use it in production. There are basically three methods available inside SQL Server. SP execute external script, that was the way to do it in 2016. A very secret way, SP RX predict, that practically nobody uses, but it's there, and predict. And you can, the cool thing about this is you can see how this feature matured from seeing how the code evolved in each of these three different ways to do it. Each one of those has its advantages and disadvantages. SP execute external script supports R and Python. It's not dependent on RevoScalar or Microsoft ML algorithms. And I'm specifically mentioning this here because RevoScalar and Microsoft ML are separate libraries inside Python and R, in which Microsoft built a number of optimized algorithms. And the reason for that is in R, there always is a huge problem. If you have a data set that's larger than the memory of your machine, R will crash. And there was a company called Revolution Analytics that thought, well, like, okay, we're going to fix this problem. So the way they did that is they would get the data set, put it in chunks, and then process each chunk individually and do it parallelized, because R is always single-threaded. So they built new models, new linear regression models, new neural networks, new decision trees that can use parallel processing and can distribute the data across multiple threads, something R could never do. And then Microsoft was like, yo, this is really cool. We're going to buy you guys. And they were like, okay. And now they are integrated inside Microsoft. So if you see something like a RevoScalar algorithm, it used to be the Revolution Analytical algorithm. The Microsoft ML algorithms have the same technology to make it more complicated, but were developed by Microsoft themselves. And now they both collaborate on that stuff. So you can download the Microsoft ML and RevoScalar algorithms on your R as well if you want to. They're also for Python. Little bit of history. There is also some things that aren't really cool. The SP execute external script is an external process, and I'm going to show it a bit later. And it requires the in-database R or machine learning feature enabled. So when you install SQL Server, you have to enable a checkbox so you can use SP execute external script. The other option is SPRX predict, and its only main advantage is that it's really, really, really fast. What it actually is, it's a CLR. Is everyone familiar with CLR? It's like a DLL file that gets loaded directly in the SQL memory space. It's just C# code that's integrated in SQL Server. So it's very quick. I'm gonna guess that this has been developed to enable real-time scoring, like sub-millisecond predictions on data, because it's that quick. It only supports R. It requires CLR integration, which is All the database administrators in this room are going to go, oh no, not CLR integration. It's the biggest security risk you can have on SQL Server, because you're basically telling SQL, oh yeah, you can take over the entire control of my operating system now by enabling it. Hackers love it. It only supports revoscalar. It only returns predictions. And again, it requires the feature, which is kind of weird, right? Why am I still saying it requires the feature? Because I said it's a new feature in SQL Server. Because the predict keyword that was introduced in 2017 doesn't require the feature to be enabled. So if you are running SQL Server 2017 now, you have in-database machine learning, whether you want it or not. It's there. It's automatically enabled, but only with the predict keyword. So you can do the fancy things SP execute external script can, which we're all going to look at in a moment. It supports R, it supports Python. It's faster than SP execute external script, but not as fast as RX predict. And it's easy T-SQL integration. And if you are a database administrator and you were going to work with this to store the models, it's very easy to use. You will understand this. You do not need to understand R code or Python code or Java code to do in-database machine learning. It's only SQL Server 2017 or higher, 2019 for instance, and it only supports revoscalar algorithms. We're almost at the good stuff, guys. Hang in there. Quick look how SP execute external script works. SP execute external script is a separate service called Launchpad. And for those of you who have a SQL Server and have in-database machine learning enabled, and you looked at your services that were running, or your running process, you would see a Launchpad service. What they actually do is that when you enable the feature, Microsoft installs a version of R on your SQL Server machine. You also get a license agreement that you have to click. They install a separate version of R inside your SQL Server machine. What the Launchpad service actually does, very simple, is that when you send data to in-database machine learning, to R or Python, it will send it to the Launchpad service. The Launchpad service will process it into something that R understands, sends it to the R.exe, literally, does its stuff, and sends the results back again to SQL. So we're kind of being tricked here. So we're leaving SQL and send data to a separate process and get back the results. That's what SP execute external script does. In predict, that's no longer the case. So that's why you need to check that little box to install in-database machine learning services, because it installs a local version of Python or R and the Launchpad service. All right, demo time. No questions so far? Anyone using in-database machine learning or something already? Okay. Sounds familiar? Was I telling the right things? Okay, good. Whew. Let's see. Okay, so I'm quickly going to see if I have another file here, because I kind of promised we were going to do something cool. Yeah, this is kind of weird. I was guessing there was the correct demo file so we could do the Halloween stuff, but apparently it isn't on my machine anymore, which is too bad. So what I was going to show you to make it even worse is I was going to show you a model I trained for Crazy Data Science that would predict whether you were going to die in a horror movie. I should have prepared this better, but I was like, okay, the audience is going to be really serious, but we already shared a couple of laughs together. So I was like, well, maybe we can do this. But I was like, this is a serious conference. I have to predict car prices. So I'm sorry. But to go to the end result, I was going to die in a horror movie. Yeah, I'm sorry. So back to the car prices. What we are going to do is we got our car data here. I've already shown you that, and I'm already going to do a small split inside this data to do, again, testing and training. So I'm cutting my data set in half. 10% is going to be our testing table, and 90% is going to be our training. So I'm creating, using this T-SQL code, creating two new tables. All right. And I'm going to create a table. I'm going to create a table called models, because within database machine learning services, I can store my machine learning model inside SQL Server in a table. So I don't need to store it in a separate R script file on a machine or something. I can store it directly inside my SQL Server database. Let's do that. And let's train our model. You need to have external scripts enabled before you can use this. And we're going to train a model. I'm going to drag this down so it doesn't get in the way. Results. This little bit of code is doing the sp execute external script. It's a stored procedure in SQL Server. We have a number of parameters, and the first one is language. And this, in this case, is R. This is an R script, but it could also be Python. It could also be Java. Next line is script, and here's where things can get quite complicated because this is all SQL code, but everything that's between these characters is R code. So this is, if you paid attention during the traditional way, this is actually practically the same thing I typed in my RStudio. So this is all R code. It will create a variable called automobiles linmod, which is a linear model, going to predict price based on all these variables. The data is automobiles. I'll get to that later. To see if you're using a revolution scalar algorithm, there's always an Rx in front of it. So this is a revo scalar algorithm. So this is, our data set isn't that big, but it gets partitioned and it gets multi-threaded processing. Then I'm going to store a variable called model, and I'm going to call a function Rx serialize model. And this is a way to basically squish down your model into a binary string and return that as output. So I can store it in a var binary column in SQL Server. So that's how you can store your model directly in SQL. Again, Rx, revo scalar. You need to use the Rx serialized model on an Rx algorithm, or else they won't work together. It takes our model object, sets a parameter that we can all forget, and it does something. The other parameters tell us, okay, what is going into the R script and out of the R script. So the input data1 parameter is a query, select star from automobile train. It also has a name, automobiles. And as it turns out, the name that I define here is the name that's used by the R script as data. So I kind of have to map SQL variables to R variables. So here we only have like one input set and we have a model that comes out of it. Imagine if you have 30 or 40 variables that you have to get. Things can get really, really ugly. Model is model output. So this is another parameter. Model gets returned. I have to map it to a SQL data type, in this case a var binary max, and it's an output. So this model is translated to this model, which is then translated to this model, which is declared here. So this is kind of like inception. You have to go deeper and deeper and deeper into parameters, but eventually we get our model out. So when I run this code, I'm also going to immediately insert the model into my model table. So I'm going to run this. It's going to train a machine learning model now. It's done. And this is actually pretty neat. You can see how much rows it processed, what the chunk time is. The chunks are by default, I think, 10,000 rows in revo scalar. So this is only 147, so it went really quick. But you can see it processes each chunk separately. So you can get the data back from R. You can also do R things here. So for instance, if you return, like, what's it in R, print, I think, or something, something back to the console, it gets returned in the message window in SQL. So you can also return variables and stuff in the message window if you want to see how it looks like. So if I look into my models table, I should have a model here, which I do. Our automobiles LinMod, version 1 with our object. Now this is really useful for when you're doing this in production, because consider that the data scientists, they made a better model. And they said, okay guys, we created a way better model. We stored it in SQL Server. Can you guys, in the production environment, change which version of the model you use? And the data scientists can store it directly in SQL, and the people that run the SQL scripts can just easily update their query to use a new version. So you can keep track of all the versions inside SQL Server and keep all your model management there, if you want to. There are other ways to do that, but it's a lot easier to integrate. So now we've trained our model. I'm going to show you the various options we have. And we've already seen the SP execute external script, because that's the only way you can train a model in SQL Server, because that's what we just did. We actually trained a model inside a SQL Server instance. Now we want to do a prediction. And the way we can do that is more or less the same. I'm going to get our model from our model table. So I'm going to select our model object from models, where model name is that one. I'm going to set it as a parameter, and I'm going to declare some script. So the first thing that I'm doing is that one of my parameters is that lin model thing again. So here we're mapping our parameters to T-SQL parameters again. So this is my input parameter, which is my model, that I'm selecting from my table. So I'm dynamically selecting the latest version of the model, sending it to my R session. It gets returned as a model parameter in R, which I have to unserialize, because right now it's just a var binary string. So it can't do anything with it. It needs to unserialize it. And also for the people who are not very familiar with algorithms and things like that, it all sounds very exciting. Oh, we have to flatten the algorithm. We have to serialize it. But an algorithm, in most cases, is nothing else than a mathematical equation with a couple of numbers pre-filled in. So if you're training for 3 days on an algorithm, it's a mathematical equation. So normally algorithms aren't huge, with some exceptions like very complicated neural networks and stuff like that. But a linear regression algorithm isn't something you can train 3 weeks on an algorithm like that and have a file of 2 bytes or 2 kilobytes that has your entire algorithm. So to put things in perspective. Next, input data. So in this case, I'm selecting a number of parameters from our test data. So this is the 10% of our data that we cut in half, and this is the data that the algorithm has never seen before. Again, we have to do some mapping between the parameters, between R and SQL, and I can return results. In this case, I have to do with result sets. I have to, and it gets annoying really quick, but you have to declare each parameter and tell it, okay, what data type is this in SQL? So this is a float in SQL. So you have to define it for each of the things that gets returned by the algorithm, by the SP execute external script. And you can see I was very lazy because I floated everything. I was like, I'm not even gonna look if this is another data type. But what you can do then, if you've got this figured out, you can run this, and we should get our predictions back. So even though the code is a bit complicated, this is all data the algorithm has never seen before. It grabs the algorithm from inside a SQL table, unserializes it, sends in new data and predicts it, and returns all the data, including a predicted price. So I declared everything, all those columns. You can also only return the predicted price if you want to. But this is how you can do predictions. It's pretty cool, right? Pretty quick as well. No data movement involved. Everything stays inside the SQL Server machine. Remember, I said machine. Don't think about that little external process, that nasty solution. But it works. So next up, the SPRX predict. So I already made some DBAs angry by saying we need to enable CLR integration. I made it even worse by telling them to set their database to trustworthy, which basically means that put your database open for the entire world and say, look at my data. You can come here, you can get my data. Another huge security issue. But again, it's really quick. It works much the same way as SP execute external script. You declare your model. You tell what the input data is, and you tell what a model parameter is. So this is already much more simplified. I do not have to say, okay, this column is this data type, or you have to map this or that. No, this one only has two parameters, model and input data. If we run this, we only get predictions back. So remember, this is the CLR, this is the DLL, this is blazing fast. It really is. If you want to do real-time scoring, like data as soon as it comes in SQL, I want to score it, this is the way to do it. It has no configuration options whatsoever. You need a model trained with a RevoScaler algorithm and serialized the way we did it earlier, but it is very fast. So if you need real-time predictions, this is it. If you're running a gambling website or something, this might be the solution. And then in 2017, we got Predict. And now we're all cool again, because originally I'm a DBA. So I was like, all this R code in my T-SQL scripting, oh, it's so ugly. And then they said, we're going to introduce Predict. And what Predict is a function inside SQL Server, but this does not look like R code, right? This looks friendly. This looks like something a DBA can understand. Again, what we're doing, we have to declare our model, grab it from the model table, and we're kind of like joining the model to our data that we want to have scored. So the automobile test is the data set that we're scoring. I've mapped it as, or I aliased it as an A. So we're selecting all columns in automobile test. We're joining it on Predict with this model that came from this command. And we want to return everything from there as well. And the only thing you need to do is that the return prediction you need to declare as a parameter. So I have to tell it, okay, it's a float. It's for the column results. If we do this, you can see it's pretty quick as well, but we get back all the data from the test data set, and we also get the price predictions back. And the results are all the same. It doesn't matter because we're all using the same algorithm, so there is no difference between algorithms between these three versions. They are all the same. So this is the options you have in database analytics to do it. So I've shown you all three options. I personally like the predict option because it looks more cleaner, it's easier to understand. But I also understand that people who are more familiar with R tend to like this code more. It's all a matter of preference, I guess. What do you like best? Predict looks good? Yeah? Or SP execute external script? No? Just remember that since we're all predict lovers, you have to use a model that's a RevoScaler algorithm, and it has to be serialized and stored in your database. With SP execute external script, you have complete freedom. So you can do everything you can do in R, you can do in SP execute external script, including loading libraries. You cannot do that with predict. So for instance, if you want to, generate a plot inside SP execute external script and grab that plot as a var binary and store it as a blob in your SQL table, you can do that. You cannot do that with predict. So that's only something you can do, for instance, with SP execute external script. Generally speaking, I see more people use predict because the data scientists are using their RStudio to do the development and training of their model, and they're only saying, okay, here's my model, store it in SQL and do whatever you want with it. So you don't regularly see people that train models and do data exploration using SP execute external script because that is not very useful for it. question. Yes? Yeah, it gets installed. It's a good question. So if you install a package using SP execute external script, where does it get installed? It gets installed in the instance folder of your SQL Server. I think I can show it. Microsoft SQL Server. You get R services. You get bin. This is the R code that's being used with SP execute external script. And here are the libraries. So if you add more libraries, they get added in this folder. All right. Next year, I'll have the Halloween data set. It's also in one of the crazy data science videos, by the way. So you can do it yourself if you want to. We got 15 minutes left, so let's do something cool. In my previous session, I talked a lot about Azure Machine Learning. And for those that weren't at that session, you missed a whole lot of great content. But short, Azure Machine Learning is like a web service by Microsoft in which you can very easily train and use machine learning models. So it's a very user-friendly drag and drop solution to create machine learning modules and visually explore data. A good friend of mine, Tomáš Kastrun, he's a Slovenian data scientist. He also works a lot with me for Crazy Data Science. He says it's like a point-and-click adventure game that you just click stuff and magic happens. It's really awesome. But one thing that Azure Machine Learning has is that you can only get predictions back through a RESTful API. So you have to do a JSON call with your data, get a prediction, and get it back again. So that's a bit of a disadvantage. But thankfully, with SP execute external script, we can run R code. And R code can do RESTful API calls. So why not use SP execute external script to do a RESTful API call and get a prediction back? Sounds logical, right? So I got another script. That I have here. And I got Azure Machine Learning open here. This is the experiment we created. I'm quickly opening it. We're not going to predict car prices. We're going to do the other cliche one. We're going to predict what kind of plant is this. So based on some plant characteristics. So this is, for those that do not know what Azure Machine Learning looks like, this is Azure Machine Learning. So this is a machine learning model we created earlier based on data, and it has a web service output that we can see here. Iris classification. I'm quickly going to show you what it looks like. So you get a web service if you do a predictive experiment in Azure Machine Learning. You get an API key, and using that API key, you can do a call. So in this case, I'm sending in some sample data. I can do a test, and I get a scored label back. So in this case, this plant is of the type Setosa. Are there any people that are familiar with plants? Thankfully, because I have no idea what it means. Seriously. I just use the demos. But what we are going to do is we want to get this result back from Azure Machine Learning and store it in SQL Server. So I'm going to create a table inside the Iris database. That's going to be named Iris. And I'm not only going to do some Azure Machine Learning stuff, but I'm also going to show you that if you store a model in your database, how you could use it when data comes in and you want it to be predicted and things like that. The first thing I'm going to do is I'm going to create a stored procedure called SP predict Iris. And it has a number of parameters, and it will return a predicted species as output. Don't be scared by the code, because it's a lot of code. It's a lot of code. It has my API key here, the URL here. So I think this is getting recorded. So everyone who sees this session later is going to call my API to get identified plants. You can get my API key. and it will return the predicted species. So this is just SP execute external script, right? The same thing we did earlier with the car prices, only this time we're doing a RESTful API call. I'm going to create it, and I'm going to use it. So I have to declare my output. I'm going to do execute SP predict iris. I give a number of parameters that the model requires, and I will get a predicted species back. And what this will do, underneath the hood, it will start up that little R process using that Launchpad service, do a RESTful API call to our Azure Machine Learning services, says, here's my data, sepal length is 5, sepal width is 3.2, whatevers, and give me my output back. And it will get the output back, and that it will return as the output variable of a stored procedure. Everyone gets what we're trying to do? We're all on the same page? It's almost magic. So let's try it. And we have an error. Because I think I got the wrong scripts. No, I did not. Bad access. Okay. Let's try it again, because sometimes it takes another try. It could also be the firewall. Which is disabled. No. It's not recommended to turn off the firewall, I know. Oh, it works! We actually get a value back. And this value comes from Azure Machine Learning. And if those errors didn't tell you I wasn't lying, you can actually see in the messages that we have connected to Azure Machine Learning. We used our API key, we gave it our data, and it gave us something back. A bit of content, JSON, all this interesting stuff. You can also, you can disable this as output, but we got a prediction back, which is the most important thing. Now, how would you use this in production? You would use this if your data scientist really loves Azure Machine Learning, for instance. But what you can also do is you can take this a step further, because right now we're doing things on demand, right? We're running our prediction thingies, we're doing it when we want to. But how would you normally do that? You would schedule it, so data would get stored in your SQL database, and then you would say, okay, on every 10 minutes, do a prediction on all the data that doesn't have a prediction yet, or something like that. But what I would like to do is when someone enters a certain characteristics of a plant, it's very important in the world of plants that you get a prediction back immediately. It needs to be real time, because the person that's identifying this plant needs to know immediately what type it is. So to tie this all together, what I did is I created a trigger. Is everyone familiar with SQL triggers? Basically means as soon as someone inserts a new row inside this table, I want you to do an action before you do the insert. And my action is get the data the user inserted in the table, send it to Azure Machine Learning, do a prediction, get the predicted result back, and then store it inside the table. This is like almost real-time scoring. As soon as data is stored in the table, it gets predicted. So if you store your model inside your SQL database, the process is still the same. You would store it inside your SQL database. You don't have to go to Azure Machine Learning, but you can immediately grab your model from your SQL Server database, do a prediction, and write it back before any user sees that the data is stored. So instead of storing the data with a predicted value is 0, and then do the prediction and update it, you return, write back all the data, including the prediction. So I have to do some T-SQL stuff here. I'm creating a trigger. And the trigger executes our stored procedure. So it gets the value, user inserts a new row, get all those values, send them to the stored procedure, and insert it together with that predicted output. Like what type of plant is it, insert it in the table. So I'm going to run this. And this is what one of your users would see. So a user would say, okay, I'm staring at a plant right now, and I've measured everything, all the sepal and petal thingies, and I'm going to insert them now. So he would write an insert query, insert into Iris, declare the variables, and give in the values. So notice there is no predicted species or anything here, right? That's what our trigger takes care of. So I'm going to run this. And I see the messages, so I know, oh, it has done something with Azure Machine Learning. Interesting. Let's see. And if we now select that record, you would see we get all the values we've inserted, including the predicted species it got from Azure Machine Learning. Again, I'm seeing all the DBAs in the room going, no, Enrico, don't tell them about triggers. First you told about CLR integration, then database trustworthy, and now you're talking about triggers. This is not generally a good idea to do. If you have a very busy database with a lot of inserts, every insert has to wait until the trigger has been completed. And then tying it to a web service that may or may not be up is actually a pretty bad idea. So use triggers with caution. I had to say that because if you do that in production and you say, oh, everyone is waiting so long for their inserts, it's triggers. There are other options available. You can do a service broker in SQL Server, which is kind of like an option that you can insert it into a queue and then it will process the queue and update it, to keep it simple. If you have something that doesn't have a lot of updates or you're going to do batch processing, then a trigger can be fine if you're not expecting it to be back quickly. Again, this is to Azure Machine Learning to make it even worse. If you're doing a linear regression algorithm and it's stored in database, the prediction speed is probably going to be sub-milliseconds, so it won't be very noticeable. But word of caution, be careful with triggers. I've done my duty as a good DBA now. Let's insert another row to show you I'm not making this up, because this should be another species. So it also detects other species types. So it's not just Setosa that it's returning, it actually returns the correct species. All right. So, in summary, we looked at advanced analytics, then history, and how you can do it now within database analytics. We built and we trained a model directly in SQL Server. So this is really cool, right? Because you know those database administrators, they always have those huge SQL Server machines with like 1 terabyte of RAM and 64 cores. You can use that to train your algorithms. Just don't tell them, all right? We looked at all those various methods you can use, and as a kind of a bonus, we connected it to Azure Machine Learning, but also learned a bit about triggers. So how you can use a trigger to do more or less real-time scoring. So are there any questions left? Sir?
Can Azure Machine Learning store the model directly in SQL Server?
So the question is, can Azure Machine Learning store its model in SQL Server?
Yes.
No. Sorry.
That would be great, because you have a graphical interface.
Yeah.
It's safe to...
Yeah, that would be amazing, but unfortunately it isn't possible. Yes?
There are options to do machine learning, so this is one option to have the machine learning integrated into SQL Server.
Yeah.
Amazing for people that want to keep doing things on-prem.
Yeah.
You can also do the same kind of machine learning in the cloud,
Yeah.
using Databricks, for example, and Spark. What do you think would suit better company? How would you make the decision to do it either on-prem
or in the cloud? So how would you make the decision to do your machine learning in the cloud or on-premise? I always tell people that want to start with data science and advanced analytics, try it out in the cloud first.
Oh.
The reason is that it's cheap and it's flexible and it's easy to start. So for instance, you name Databricks or Spark, which are big data clusters, right, for unrelational data or for distributed computation. If I want to have that on-prem, I need to invest a lot of money. to get the same capability that I can get by running Databricks in Azure. Because I can spin up a Databricks in Azure, do a couple of tests, and pay, I think it's the cheapest one is 40 cents an hour. So with 2 nodes, that's 80 cents an hour. So I toy around. So for €4, I can do machine learning in Databricks, instead of having to invest 50,000 euros to buy all the hardware and do it myself on premise. So that's what I usually advise. Try the cloud first. And in the cloud, yeah, there's a huge difference on why you would need Databricks or why you would need Azure Machine Learning or why you would need other stuff. One big thing that's coming out for especially the SQL people and the data engineers and data scientists, in SQL 2019 is going to be a feature called Big Data Clusters that's going to combine Spark and SQL Server in one environment. So you can have an on-premise data lake environment, so SQL Big Data Clusters. You can also run that in Azure, by the way, on Kubernetes. So then you have everything you ever wanted in one product. Yeah, or in the cloud. Yeah. Yes, sir.
When you're training based on data sets that have billions of rows
Yeah.
in SQL Server, is the data being copied out of the SQL Server context, or it's basically what are the restrictions? Like if you have some memory limits.
Yeah. So the question is the data, when you train it with SP execute external script, is it getting moved out of SQL Server to the Launchpad stuff? Technically, yes. So kinda, but in memory. And because it's all Revolution scalar, normally, it would get, the memory usage would be acceptable because it can manage it itself. If you're using native R code, you can actually kill the SQL Server by using all the memory. So you have to be careful there. So that's why I also said normally you would train your model on a different server or with a different product and then just store it in SQL Server. So you don't want to do model training on SQL Server. Even though the terabyte of RAM and the 64 cores are very inviting, it's generally not a good idea.
Second question, when you want to score billions of rows, how would you normally do it?
How would you score billions of rows? You would do that through, for instance, a separate process that would just run, not with the trigger. So you would store the data first and then run a query script that does update everything that hasn't been predicted yet. And because, like I said, the trained model is just a mathematical equation, so it's very small, so that will be a very fast process. Yeah.
So that would be not a data set operation, but a kind of loop, right?
Yeah, you would need to do a prediction for each row. So you can't do it for the entire set. It would be a row by row operation. Correct. Yeah.
To run those R stuff in SQL, do you need to install additional features, or it just works out of the box in SQL 2017?
Okay, so to use additional R functions, do you need to add an additional feature? If you want to use SP execute external script, yes. If you're only doing predict, no. But in most cases, yes, you need to install the Azure Machine Learning service. Yeah. All right. I want to thank you for attending the session. You've been a great audience. I hope you enjoyed it.